कि नहीं कि I don't remember that actually. You have this in your notebook?
Yes, sir, it's written. I have written
It's written?
everything.
Yeah,
This
okay,
also
fine.
the first one, like I had missed, I came like half an hour late, I think, but I wrote everything.
Ah, okay, fine. Okay. That's why I think you're having some difficulty here. Acha. So see, let's just talk about this. Okay. So you see that we have zero order reaction. Rate will be equal to this K into A to the power 0, where concentration terms becomes completely 0. But a rate will always have this particular unit. That means concentration upon time. जैसे speed के लिए आपके पास you have what speed is always meter per second, right? Similarly, we have concentration per unit time. That is the rate, the unit of rate always. Okay, always that is a unit of rate. Okay. Now, if that is the unit of rate, what will the unit of rate constant? Now, in this case, in this particular case, we have only K, and its unit will also be equal to mole per liter per second. Is that right? यहाँ तक समझ में आया आपको? For zero order reaction, this will be the now. For first order reaction, what I'm going to do? See, A is giving me B. Rate will be equal to the rate constant multiplied by the concentration of A to the power 1. Now, if I write about K, then K will be equal to, please see here, rate upon A. K will be equal to rate divided by the concentration of A, right? Now, the rate has unit of mole per liter per second, and concentration has a unit of mole per liter. So this both units will get cancelled, and the unit of K will become just second inverse. Can you see that? Yes or no? Tell me.
Yes, sir.
Similarly, for second order, what is going to happen? The rate is going to be the same, but now concentration will be mole per liter squared because we have order which is equal to 2. ये भी आ गया आपको समझ में?
हाँ, sir.
ठीक है. Now what you have to see is you have to see the, if you want to determine what is the order from unit of K, just look at the unit, just look at the power of L. What is the power of L here? What is the power of L here?
Minus one. It's given.
नहीं मोल का
अच्छा.
है ना वो तो. हाँ, L का क्या है?
L is okay, 1. Then
1 है ना? L is 1. What about here? What do you think? What is the power of L here? If you don't have
0.
हाँ, L की power 0 है यहाँ पे. And what about here?
Minus 1.
Minus 1. So I think we can see that if you have minus 1, then just add 1 to the power of L, you will get 0. Add 1 to the power of L here, you will get 1 because 0 plus 1 is 1. Again, here add 1 power of L, you're going to get 2. Okay, just add 1 to the power of L in the unit of rate constant to get the order of reaction. Got it?
Yes, sir. So like for all the numericals, the K will be given, and then from there you identify the order.
Yeah. Otherwise, they will just give you this the order of reaction. And once you have identified the order of reaction, then what you need to do is you have to identify, you have to see that you are going to use the integrated rate law equation. Okay. So for example, if you see the first order reaction takes this much minutes for decomposition, calculate the time when 75% of the reaction will be complete. So now we have written this particular equation. Why? Because we know that it is first order. So first of all, you will determine, then you will write the appropriate integrated rate law equation. Okay. So there is only 2 equations that you have to learn actually, like the equation for the zero order and equation for the first order. अब वहां पे अब इसी इक्वेशन में से आपके पास देखिए क्या क्या चीज वो पूछ सकते हैं. They can ask you either K, they will give you the rest of the things. They can ask you time, they will give you rest of the things. They can ask you initial concentration, they can ask you the final concentration. These are the variables and they are just going to not give you directly, but उसके लिए आपको थोड़ी मेहनत करनी पड़ेगी. Like for example, 25% completion, it means that if 25% is complete, 75% is remaining. So they have neither given you the initial concentration nor the final concentration. But if 25% is complete, that means initially we had 100 and 75 is remaining. That means 25 of the reaction is complete, 25% of the reactant has reacted. Are you getting this? Yes or no? Tell me.
Yes, sir.
So like, please redo these questions. Okay. First thing is that you will have seen all of these questions, you will only get, even for the T half also, if you are going to calculate for T half, then the T half for zero order is going to, the T half for zero order is going to be this, A naught by 2K. And for the first order, it is going to be simply 0.693 upon K. Okay. Now, first of all, the main thing is that you have to identify what is the order of reaction. Fair. I think we did a few of these questions. Then we did pseudo first order reaction. Okay. What is the question? See, now here what you can see is that half-life of a decay, for decay of radioactive C14 is this many years. An archaeological artifact containing wood has only 80% of C14 activity as found in the living trees. Calculate the age of the artifact. Okay. So first of all, you have to see here that what they have given you the half-life. Now, whatever radioactivity happens, all the radioactivity, it happens through first order reaction. So we can write K will be equal to, sorry, not K, the T half is equal to, we know that 0.693 divided by K. If I know the T half, then I can calculate the K as 0.693 divided by T half. This will be equal to 0.693. T half is 5730. This will be year inverse, right? K we have calculated in terms of year inverse. Okay. Now what we need to do? Containing wood has only 80% of the C14 activity as found in the living trees. Okay, so if the living trees has 100%, our artifact it has only 80%. That means 20% has reacted. Is that clear? Yes or no? Please tell me. 20% has reacted, and how much is left? 80% is left. Now, what is the first order integrated rate law equation? KT is equal to 2.303. Yeah, no? KT is equal to 2.303 log A naught upon A. Now you need to find time. So time will be equal to 2.303 upon K log of. Initially it was 100. How much is remaining? 80 is remaining. Now this will be equal to 2.303 divided by K is equal to, we'll multiply 5730 here, divided by 0.693, 0.693, and log of this will be 4, 2 4s and 2 5s, so 5 by 4. Log 5 by 4. The time we are going to get will be in years. So calculate this one. One value I think that you should remember, which will be helpful, is two 2.303 divided by 0.693. This will be 3.23232323 and so on. Okay. So I think if you remember this value, it will be very helpful. Calculations आपके काफी fast हो जाएंगे. 3.23. So now this will become into 5730 into log 5 upon 4 will be equal to what? 0.70 minus 0.60, 0.1. Can calculate 5730 and numbers. 3. नबील खान, अस्सलाम वालेकुम। हेलो नबील,
ये सर वालेकुम सलाम।
आप इलेक्ट्रोकेमिस्ट्री वाले बैचेस में आ रहे थे ना?
ये सर
फिर आज यहाँ
सर
कैसे
वो
नाशी करें?
लर्नियो वाले लिंक शेयर करे, बोले कि ज्वाइन करो।
आपने नहीं कुछ बोला। आई एम गेटिंग मैसेज दैट यू आर हैविंग रेगुलर क्लासेस फ्रॉम 7 to 9। आपने टाइमिंग चेंज करने के लिए बोला था क्या
ये
क्लासेस के?
सर
अरे तो फिर आप बोलिए ना, आपने बोला था, लर्निंग वालों ने नहीं भेजा। ओके। सो लेकिन अभी यहाँ पे तो आपका ये खत्म हो जाएगा, केमिकल काइनेटिक्स खत्म होने वाला है।
ये सर
और फिर इलेक्ट्रोकेमिस्ट्री स्टार्ट होगी। सैटरडे संडे में क्या दिक्कत है आपको?
लाइक आई हैव ट्यूशन फॉर फिजिक्स
यू हैव ट्यूशन फॉर फिजिक्स एट व्हाट टाइम?
फ्रॉम 7:30 to 9।
फ्रॉम 7:30 to 9
यस
and chemistry starts from 9 or nahi? When does chemistry okay,
केमिस्ट्री स्टार्ट्स एट 6, तो 6 to 8 हो जा रहा है।
6 nahi 6:30 I think, right?
या
Saturday Sunday 6:30 है ना?
उससे पहले लाइक 4 to 6 मैथ्स पे है।
फिजिक्स आपका कहाँ पे है? लर्निवियो में ही है?
नहीं नहीं, फिजिक्स अलग, लर्नियो को छोड़ के।
अच्छा, कहीं और है। लेकिन फिर आप फिर और किस दिन टाइम है आपके पास? लाइक इलेक्ट्रोकेमिस्ट्री की अगर हम बात करें तो सैटरडे संडे को 2 बैचेस में होता है। यस मोहम्मद साहब, दैट इज करेक्ट। एंड देन
सर
आई आल्सो
इट्स ओके इफ इट्स पॉसिबल टू लाइक मैथ्स हटा के लाइक 4 to 6 कर दी केमिस्ट्री।
केमिस्ट्री 4 to 6 कर दें।
हाँ वही 2 दिन।
सैटरडे संडे चलेगा आपको केमिस्ट्री 4 to
हाँ
6?
या
आप हमको मैसेज कर दीजिए सेम चीज। सर प्लीज शिफ्ट माय बैच टू 4 to 6।
ओके।
नहीं, आस्था, दैट इज नॉट करेक्ट। फिर से ट्राई कीजिए आस्था। हाँ खलील, दैट इज करेक्ट। आस्था, आपका केमिस्ट्री का एग्जाम हो गया या फिर कब होना था?
Yes, sir. Yes, sir.
अच्छा, आई थिंक आई हैव आस्क्ड अबाउट यू दिस नो। हाँ पूछा था हमने पहले भी। सो दिस आंसर हियर इट इज 1850। Let me just recheck. Yes, Nabeel. ओ नहीं, अच्छा। Let me see. It's coming a bit higher in the calculator. I don't know why you guys are getting. चल ठीक है, चलिए इसको भी ये कर लेते हैं। ठीक है।
Sir.
एक चीज आप लोग इसमें ये कर लीजिए प्लीज, दिस इज 3.32 नॉट 23, ओके, इट्स माय बैड, 3.32. हाँ, yes, Asa, tell me.
So till when the portions will be over? Like full.
ये complete syllabus
हाँ.
somewhere around November. Somewhere
Okay.
around November, okay.
So like on November's last week, our prelims will start, like the mocks. So like pura textbook they'll put for exam.
हाँ हाँ, वो तो पता है, लेकिन वो कैसे खत्म होता है उनका वो भी आपको पता है ना, तो गुड थिंग्स टेक टाइम,
Yes, sir.
है ना. सो थोड़ा आप सब्र रखिएगा, ठीक है, बट अगेन ऑल द लेक्चर्स विल बी अवेलेबल, ओके. फॉर एग्जांपल इफ आई एम डूइंग फॉर एग्जांपल if I'm doing chemical kinetics here, electrochemistry lectures are available, okay. And similarly जब ये आप खत्म होने लगेगा, and even if you want to, like for example aldehyde ketone से आगे आपको अगर कुछ चाहिए होगा amines वगैरह, तो all those lectures will be available. So क्लासेस नहीं हो रही होंगे अगर उसके, हम लोग थोड़ा सा पीछे होंगे, लेकिन लेक्चर्स होंगे, आप अगर खुद से पढ़ना चाहते हैं तो खुद से पढ़ सकते हैं, लेकिन बाय नवंबर द सिलेबस विल बी कंप्लीट, ओके. आई विल नॉट कमिट टू समथिंग दैट आई कैन नॉट डिलीवर, राइट. अगर हम बोल भी दें आप लोगों को कि नहीं हम अक्टूबर में कैसे खत्म कराएंगे, है ना, अक्टूबर में इट्स ऑलरेडी 4th October एंड वी हैव नॉट completed this chapter, so till November I will complete the whole thing. Abhi, for that if I want to have, even if I have to take some extra class, that's fine, but by November this will be complete, inshallah. Okay, now write another question. This one I had to help you guys, so write one more and then we'll move to collision theory. Now if you see all of these questions, they give you some information and then they expect that you first of all get out some value, and then you again, for example this statement here, 20% complete in 5 minutes, this complete information is going to give you the value of k, okay. Now once you have got the rate constant, that rate constant is not going to change. You have to calculate now the time to complete 60% of the reaction when the 60% is complete. Okay, so for a first order reaction, write the integrated rate law equation what it is and then calculate the k. You have now this 20% में क्या है मिला हुआ आपको, you have the initial concentration as well as final concentration, right? So these things you have to start to identify, and you have to notice these things, that when they are writing 20% complete, what does this mean? It means that my A naught is equal to 100 and A, the remaining portion of my reactant, is 80. Okay, that's something that they will not explicitly give you. ये आपको आ जाना चाहिए, बहुत सारे सवाल हम लोगों ने कर लिए. Then you should know that I have now, when they have given you time, then they are asking me about the rate constant. When they have given me time, then what they are asking, then when they are having, when I have got the k, then I can calculate the time. Okay, so do this. First of all, calculate the k, send the answer to me. In the previous question also, they were hinting you about the k by giving you this particular information, that the half-life is this much. So there are multiple ways in which they can hint you towards the rate constant. Either they will give you one situation in which they are giving you time and the percentage of the reaction is complete, or sometimes they will be giving you half-life. Okay, so these are the things that they are going to give you, but again, all of these will be hinting towards your k. Okay, Astha and Minashi. Okay, both of you are getting same answer. I think that must be right then. So what do we have here? We have K will be equal to 2.303 divided by the time taken and log of E naught by E. So we have 2.303 divided by the time. Time is equal to how much? 5 minutes. And it's log. It's log of 100 upon 80. Yeah, that's quite right. That's quite right. Then further, you can calculate the time also, right? You'll get the same thing. Time is equal to 2.303 divided by K log of A naught upon A. Now here the same thing. Here it is 60% complete. Right. So what will happen? This A naught will be same, but the A will be different here. And you will get the time. The K you are going to get from here. Whatever the answer you are getting in minute inverse, and the time you will be getting in terms of minutes. Okay, that many minutes. Let us see. It's a bit less, but I don't know. It may be also correct because no, Khalid not. No, I don't think that is right, Khalid. I don't think that is right. I think you put here 60, but 60% is complete. So tell me about how much is remaining. How much A is remaining? How much of the reactant is remaining? You have to put that number here. Okay, Minashi. I mean, yeah, correct. I think also you're saying 40, and that will be 40. No, log it will be 100. Now, initial concentration 60% means what? 60 out of 100. So initial was 100. 100 versus 60 complete. Like 60% of the reaction is completed. So how much is remaining? That you have to write here. It's 40. And first of all, send me the K, I think. What is the value of K you got, Khalid? Mohammed Saif, not that much, quite. Not right. फर्स्ट ऑफ ऑल सेंड मी द के ना, आप लोग अगर के ही सही नहीं रहेगा तो हाँ दैट्स करेक्ट, राइट Khalid, के इज फाइन. नो 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 सैफ, के में आपने कुछ ज्यादा ही वहां पे मिस्टेक कर दिया है. Like you have taken a large huge approximation maybe, that is why. What I have always said is that I think you guys must remember me saying many times, two non-zero digits after decimal points. ठीक है, two non-zero digits after decimal point. हाँ ओके खलील चलेगा, that's fine, that's acceptable, that's acceptable for K. So the answer that you will be getting here is 0.046. Okay, 046 or 044, something like that. Okay. So plus or minus 2 you can see here. Okay, 0.002 plus or minus. And the answer time you will be getting here is somewhere around 20. Okay, 20 minutes के approx आपका आंसर आना चाहिए. Okay, so I think you guys are getting a hint like how to approach these type of problems. Okay, I think I'm going to move on to the next topic, that is collision theory. If someone is doing some mistakes in calculation, the only solution for that problem is going to be practice, nothing else. Okay, so if you practice more and more problems, then there will be a time that where your brain will not be working, like your hand will be just writing the answers. So whatever we do in the class, please redo those questions at your free time when you self-study. That will make your numericals a bit better. But again, yeah, if you're having some problem in thinking about what particular type of or what equation to use or which formula to use, if you're struggling in those things, then I will suggest that you ask me, then I will help you guys. Okay, so I think this question made things clear for you, and the previous question mainly आपको इसी तरह के सवाल मिलेंगे. Either they giving half life जहां से आपको k निकालना पड़ेगा, or they will be giving you some situation 20% complete है, 60% में कितना टाइम लगेगा. ठीक है, चलिए moving on to the next topic, please write collision theory. Collision theory. Okay, so what is collision theory? So don't write Abhi. Let me just explain this thing. Then we are going to write about the collision theory. Collision theory says that the reaction, it happens only and only when two molecules can collide. Okay, fine. So the first condition that they're saying that a reaction happens only and only if two reactants collide. Okay, that's fine. And this collision should be, for example, if I have a molecule which is, let us say, red colored, and I have another molecule which is, let's say, blue color, right? So if they are colliding with each other, this collision should be completely head on. I mean, this is one of the condition you can say. And let us suppose that there is another collision which is like this. If you can see now, these two are also colliding with each other. I mean, this is going in this direction, this is going in this direction. So obviously they are going to touch each other, right? They're going to touch each other. Now there will be some collision which will be something like this. When two atoms collide, there will be something like this also. Now in this case, they are not completely head on, but still a major portion of it is colliding with each other. Now we have three cases, A, B, and C. What do you guys think? Which is the best collision, A, B, or C?
A.
Which is the A? how many of you agree with this? Which is the best collision?
Sir, A.
A, right? Yeah, correct. So A is the best collision in which we are having a head-on collision. That means not all the collisions. For example, this, if you take this example here, this collision is not going to make any sense because only this portion and this portion of the reacting species, these are colliding. The complete molecule is not colliding with each other. That means all collisions, they will not lead to a successful reaction. Okay, so for example, these are not going to lead to a successful reaction. That means a very minute fraction of molecules which collide with each other with proper orientation, they are going to give us product. So first of all, collision is required. Second of all, we have to have them in proper orientation. And third of all, for example, let us suppose that this scenario is happening. Okay, this is happening. Now, in one of the cases, let us suppose that they are colliding. I don't know exactly what speed will it be. They're colliding at such as. अच्छा, tell me. आप लोग सबसे ज्यादा कौन से यूनिट से कंफर्टेबल हो स्पीड के? What unit comforts you most? Like मीटर पर सेकंड समझ में आता है कि कितना फास्ट होगा कोई चीज?
Yes, sir.
Yeah, man.
आता है, मीटर पर सेकंड समझ में आता है?
Yes, sir.
Okay, fine then. So let us suppose that this is नहीं, but जैसे कितना मीटर पर सेकंड बहुत फास्ट है, कोई बताएगा?
So even 1 meter per second.
1 meter per second. 1 meter per second. Yeah, that's fast. 60 meters per minute, and then it will be 360. 60 into 60 will be 3.6 kilometer. That's slow, man. Yes, Umar?
What, sir?
1 meter per second will be what kilometer per hour?
Something like 0.001.
0.00. That is 3.6 kilometer per hour. That's quite slow. Don't you think that? 3.6.
Yep.
Right? So वही हम बोल रहे. So I think all of you are more comfortable with kilometer per hour, right? उससे आपको ज्यादा समझ में आएगा कि स्पीड क्या है, exactly slow है या तेज है, right? Yes or no?
Yes, sir.
Okay. So if I have, so that means if 1 meter per second is equal to 3.6 kilometer per hour, so meter per second में ही देंगे. And so I can say that कितना से multiple 10 will be 36. 36 भी बहुत ज्यादा नहीं है. 100 meter per second. 100 meter per second will be 360. That is quite fast. So for example, in A case, the molecules are having 100 meter per second. In the B case, it is let us suppose in the B case here, these are 10 meter per second, है ना? दोनों की स्पीड क्या है? 10 meter per second, 10 meter per second है. And let us suppose in the C case, it is as we expected 1 meter per second. And let's also have a D case. In which it is 0.1 meter per second. Achha, what do you think, guys? Which is going to be the most effective collision here, A, B, C, or D? What do you think? Which is going to give us results? Which is going to give us some reaction can happen? A, B, C, or D?
A.
Right? How many of you agree with A?
It's, fast.
Yeah, it is fast, and most of the it's fastest. Yeah, correct. If it's fast, then what is going to happen? The complete molecule is colliding with each other. If it is very slow, they will just touch each other, and that is not a proper collision also. Yes
So
or no?
even
Please tell me, guys.
More energy would be released, right?
More energy will be released.
Is that correct?
I mean, the release of energy, it is related with the formation of bond actually. So like if it is completely There are two types of collisions, right? Cohesive and something like that, right? Correct.
Yes, sir.
So I mean, we like whatever the energy is released, that is not due to some physical change, it is due to the chemical change. Agar bonds form ho rahe hain, then because there are attractions, new attractions mean that is why the energy is released. Okay, so all the energy that is released, it is due to chemical change, not due to any physical change. But this collision, if I talk about this collision, should be what? It should be having some threshold energy. For example, I would say that if two of the atoms are coming towards each other, two reactant molecules are coming towards each other, and they just touch each other and they stop. That means it was not an effective collision. It was not even a collision, right? So for collision, you need to have some kind of energy. There's some threshold energy. So we have seen that there are three proper conditions. First condition is what? First condition is that the collision should happen. Collision should happen. Second of all, orientation is important. And even when you have good orientation, third is the reactant species should have some threshold energy. Some एक limit होना चाहिए energy का, उससे ऊपर ही kinetic energy होगी. Then only we can say that is collision is what? It is effective collision. There should be some threshold energy. इस threshold energy से ऊपर अगर आप गए तभी effective collision होगा. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Okay. Now let us write 3 points. First of all,
Oh, sir, can you explain again the threshold energy?
threshold energy जैसे मान लीजिए 80 हम एक मतलब एक क्वांटिटी ले रहे हैं 80 मीटर पर सेकंड में अगर कुछ दो रिएक्टेंट मॉलिक्यूल अगर एक दूसरे से कोलाइड कर रहे हैं देन दे आर गोइंग टू गिव यू सम प्रोडक्ट उससे नीचे में दैट इज नॉट अ प्रॉपर कॉलिजन ठीक है तो कुछ लाइक स्पीड इज रिलेटेड टू काइनेटिक एनर्जी ना राइट उमर
Yes, sir.
now this is my threshold energy like whatever kinetic energy that corresponds to 80 मीटर पर सेकंड इतना एनर्जी होना चाहिए उसके बाद ही आपका कोई रिएक्शन होगा
Okay, okay.
okay so it should have like you understand ना कि 80 नहीं मतलब कुछ एनर्जी होनी चाहिए उस मॉलिक्यूल के अंदर there should be some minimum amount of energy that a molecule should hold while it is colliding with another molecule then only the reaction is possible then only we can say that the collision is an effective collision which is going to give us some product right
Yes, sir. Understood.
understood right next there must be collisions taking place between reactant molecules
Sir. Sir, have you completed that topic, temperature dependence?
no temperature dependence नहीं हुआ है अभी इसमें
No, no. Okay, sir.
नहीं between reactant molecules but every collision is not fruitful only small number of collisions are effective and bring about chemical reaction. Right, next. The minimum amount of energy required by reactant molecule for effective collisions is called threshold energy. Next point. There must be proper orientation. there must be proper orientation. Between the reactant molecules. Between the reactant molecules. For effective collisions.
Sir, can you show the first point also?
Yeah, sure. This is must. Done, everyone? Yes, no, please hear me.
Yes, sir, done.
Okay. Now write a conclusion. The necessary condition for effective collision now we are talking about effective collision. So for effective collision, first of all, we should have threshold energy, and secondly, proper orientation. Now, even if some molecule they are having, like for example, let us say a very huge number of molecule, they are having a high threshold energy, right? That means there is too much of random motion. Then उस वक्त क्या होगा? Orientation सही नहीं होगा. Okay, so you'll also have to remember that if we have a huge number of molecules with high threshold energy, then at that time, what is going to happen? The orientation of that collision will not be correct. Okay, regarding now the threshold energy, you must have seen some curve which is known as Maxwell. Boltzmann distribution. You must have seen this in your 11th class. It's pretty difficult to make. हमसे कहिए सही से बनता नहीं है. That's fine. Okay. So here we can say that here we have fraction of molecules or the number of molecules. Number of molecules. Just a second, guys. Yeah, sorry about that. Here we have number of molecules, and here we are going to have the kinetic energy. Now there is one question that I have asked जो लोग हमसे class 11th भी पढ़े थे. The question is, I will give you 3 points, okay? I'm going to give you 3 points in this particular curve. You have to tell me where the kinetic energy is maximum. This is your point A. This is your point B. This is your point C. Question is, where is kinetic energy maximum? Okay, Khalil. सिर्फ खलील का आंसर आया. Okay, Khalid, correct. Send the answers in chat. Where is kinetic energy maximum? At which point? Okay, Astha.
So should we draw this?
हाँ, draw this. ये सवाल मत लिखिएगा, सवाल तो आप लोग के लिए. Okay, Saif. Waiting for others. Minashi, Salman. Who else is here? Muhammad Umar. Okay, Minashi, correct. Okay, Minashi. Okay, Salman. Fine. ठीक है. So, अच्छा. See, when they have asked, where is the kinetic energy maximum? So, is kinetic energy is in some of the axes? Astha, tell me. कौन से axis में है kinetic energy? Astha?
X-axis.
X-axis. ठीक है. That means A will correspond to this kinetic energy.
Okay, so C, it's maximum, the kinetic energy.
Okay. So this is a rookie mistake. Like B ऊपर दिखता है, but B it corresponds to
Number of molecules.
number of molecules. That means most of the molecules are having this much energy, this kinetic energy. B, right? Most of the molecules are having this kinetic energy. Okay. Fair. Now there are a few, for example, generally what people say is that here you can say that this much, this energy is the threshold energy for a reaction, and it is very low number of molecules. Okay, so only this much molecules are going to give you fraction of molecules with kinetic energy higher than threshold energy. This will be fraction of molecules with energy that is higher than threshold energy. Now A and C point, these are of no significance, but B point is of significance. We can say that, but again, इस particular class में significance नहीं है इसका. 11th standard में B का significance था. ठीक है? So B is what? It is the kinetic energy, like most common kinetic energy था वो. अगर आप लोगों को थोड़ा सा याद हो, there are different speeds. Speed, average, root mean square, most probable speed, है ना? तो kinetic energy, ये kinetic energy जिस भी speed को correspond करेगा, that will be your most probable speed. Done. Done.
Sir, after the graph, you have to draw these all markings at A, B,
नहीं कुछ नहीं, ABC कुछ नहीं करना, बस ये करना, fraction of molecules with that, that's all. Okay, write some remarks. Maxwell-Boltzmann distribution is a bell-shaped curve. अच्छा, do you know what is the name of this type of distribution? इस तरह के distribution को normal distribution बोलते हैं. Normal distribution का मतलब क्या होता है? Like this very important concept. अगर आप लोग higher studies में जाइएगा किसी भी field में, then statistics is very important. So this is normal. Normal means, for example, if you try to get the height of each person in a city, then the height will be something like this. There will be very less people with very less height. Most of the people will be having some average height, and there will be very less people with like there will be very less people with who are very tall, right? Similarly, you can do the same thing with the weights also, right? This is again normal distribution curve. If you are going to test about the IQ, then this is again the normal distribution curve. Have you seen that there are memes right now with this curve? No, not seen. For example, this. All right, so you can say that people who are like having very less followers, they don't have any social media plan. The people who are having a very high number of subscribers, they're also having no social media plan. They just put out content. Then there are in the middle people who are struggling and they need some complex content strategy. Okay, so this is again a normal distribution curve. Actually, I start noting out everything. Okay, fine. Remark is a bell-shaped curve. Is a bell-shaped curve curved between number or sometimes fractions also. Okay, fraction of particles and kinetic energy. Second point, it shows that very few particles have kinetic energy greater than threshold energy. After this, write this question. In some cases, it is found that a large number of colliding molecules have energy more than threshold energy, yet the reaction is slow. Why? So we are having a very large number of molecules that are having energy more than threshold energy, but still what is happening? The reaction is slow. This came for 1 mark. And the answer is what? Simple answer is due to improper orientation of colliding reactant molecules. And there cannot be any other reason. If you are having दोनों ही चीज सही रहता तब तो आपके पास reaction fast होना चाहिए था, but they are saying that it is not fast, it is still slow. That means the orientation must have been bad. It should have some improper orientation. Done, guys? Yes or no? Please tell me.
1 minute, sir.
No,
1
sir.
minute. Question लिख रहे हैं. Done.
Yes, sir.
Right, next. Activation energy. Activation energy, please write the minimum amount of additional energy that is required by reactant molecule to achieve threshold energy is called activation energy. Okay, so obviously a molecule will not have zero energy at room temperature because there is some temperature, and any temperature above the absolute zero. If you have any temperature above absolute zero, there will be some amount of energy that is associated with each and every molecule. Now, to reach threshold energy, we need some additional energy. Now, that additional energy is known as the activation energy. Okay, that is the difference. So, this is E threshold will be equal to the average energy of all the molecules plus E activation. Okay, E activation. So obviously, please understand this point. Okay, activation energy and threshold energy, these two are different things. Each and every molecule if it is above absolute zero, it will have some kind of energy. And when you average the energy of all the molecules, you will get E average. Then that E average will be something below than the threshold energy. अब उसके लिए जो activation, उसके लिए जो additional energy चाहिए, that additional energy is activation energy to activate the molecule for reaction. To activate the molecule for reaction. All right, next, progress of a reaction. Now see. Please listen this one, okay? Don't draw
Sir,
anything.
could you show the box one again? What did you write in box? Yeah. Now, let us suppose that this is the potential energy we are graphing in the y-axis. And here we have the reaction coordinate. Now, reaction coordinate can be anything. For example, we can start with the bond lengths. Usually these are bond lengths reaction coordinate. कि जैसे अगर मान लीजिए आपके पास A है and B है, right? Now, ऐसे देखते हैं इसको. For example, you have A2 plus B2. This is going to give you AB. If you take the bond length here, like the distance between the two A molecules, it is going to be something very little. Like, for example, we can say that it is going to be very small, 0.1 angstrom. Okay, it is going to be 1 angstrom. Now, as soon as the reaction is going to go forward, these AA, the bond is going to break, and the distance between AA molecule is going to increase slowly. And if the distance between AA molecule is increasing slowly, that means this bond is breaking. As the bond is breaking, the AB bond will be formed. So we can track the progress of reaction by just tracking the distance between two A molecules. If the molecules are separating, and then they come across some value which is now constant, that means the B product has been formed. Okay, so reaction coordinate वो होता है. Reaction coordinate. It is generally, ये पूछेगा नहीं कोई आपसे. अगर आप लोग आगे जाकर केमिस्ट्री पढ़िएगा तब आपसे पूछ सकते हैं कि बताइए BSc में गए थे, and the first thing chemical kinetics, again you have chemical kinetics, but again you have some different higher order reactions there. So the professor was like draw a graph for progress of reaction. So everyone drew that, and then the first question he asked that what is reaction coordinate? कुछ लोगों ने बोला time. उन्होंने कहा नहीं, time तो नहीं है. Then some people had some different answers. So before the formula, okay, Salman. But again, then no one gave the answer. Then the professor explained that what is reaction coordinate. It can be bond angle also. Bond angle, bond lengths, interatomic distances.
Yeah, okay, sir. Thank you.
Done? Okay. Now, let us suppose that initially all the reactant molecules, they have some energy here. This is the average energy of all the reactant molecules. And it requires some, this is the average energy. That means it will require some energy to achieve the threshold energy. Let us suppose that it requires this much energy to achieve the threshold energy. And when it will form a product, let's suppose that the product's average energy is lesser than that of the reactants. So what are we having here? This is my ET. The threshold energy. And this is my E average of all the reactant molecules. Okay, right here reactant, and this is my product. Okay, now the activation energy is going to be this. This is the activation energy because this is the additional energy that is required by the reactant molecules to reach threshold energy. This is my
E activation, or we can just write EA. It's my E activation. Now, the difference in energy between the reactant molecule and the product, this is going to be the enthalpy of reaction, delta H. Now, initially, आपके पास, this was the energy and it lowered down to P. So this is your delta H, enthalpy of reaction. Now, this is the case in which what is going to happen? We can see that delta H is equal to the energy of final energy is energy of product minus the energy of reactant minus the energy of reactant. So we can see that the product energy is what lesser than reactant's energy. Obviously, this is going to be negative, and so if this is negative, then it is going to be exothermic. Exothermic. Then you have the another one. Oh, it is happening like this.
So should we draw the graph?
Yeah, please draw the graph. You understand this one now. Again, this is the average energy of the reactant molecules. This is your threshold energy. And let us say this is the energy of the products. So you have reactant, here we have the product. This is the threshold energy. And if you look at the reactant molecule, then this is going to be your E activation. This is your activation energy. And this is going to be your delta H. In this case, these are again the same thing, potential energy. This is your reaction coordinate. And the delta H is equal to the energy of product minus energy of reactant. Product energy is higher, so this will be greater minus smaller, which will be positive. And hence this is an example of endothermic reaction. Now, the highest point in both of these reactions, the point at which it attains the threshold energy, you will get a state which is known as transition state. Okay, so the transition state is what? The molecule in the state in which the molecule is having highest energy. That is your transition state. Transition state. All of you done?
Wait, sir.
Okay. Done, guys? Yes or no? Please tell me. No, not done.
No, sir. Sir?
हाँ,
Sir?
done. Okay. जी जी
No,
बोलिए.
no, 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 no. Sir, how will they ask us questions based upon this graph?
Based upon this graph, they will ask they will ask you to plot a graph between for endothermic or exothermic reaction. Okay, they can ask you like that. They can ask you, for example, endothermic के लिए what will be the delta H positive या negative होगा. Then what is the transition state? They are going to ask you that. Okay. So what else they can ask? They can ask you draw a label diagram and then explain the significance of transition state. These things they are going to ask you guys. Okay, and what else? That's it. Mainly they are going to just आपको बस ये graph बनाना पड़ेगा, nothing else. You have to make this graph. Done, guys? Yes or no? Please tell me. हाँ, guys, done. Not done.
Sir, can we define a transition state as the point where molecules attain the highest threshold energy?
Highest बोलिए या फिर आप बोलिए the हम दिखाएंगे आपको, ठीक है? वो it's particular atomic configuration, that is a configuration of all the molecules that are taking part in the reaction, and that particular configuration of the atoms, they have attained the activation energy, or we can say they have attained the activation energy. वो जो आपके पास atomic configuration होगा, that is transition state. आप ये graph बनाइए, फिर I will explain, like I will write points for each and every. And with an example, I will also explain what is a transition state. Transition state वैसे आप लोगों ने ना उसमें देखा है in SN2 reaction, if you remember, guys. Just a second, है ना, हम बता रहे हैं आप लोगों को. You see this transition state. Right, this is between, like them बीच में होता है products है transition state, and then you have the reactant, sorry, the reactant, transition state, and then the product here. But we'll take a more simple example. Oh, what happened? Okay, fine. Draw these graphs. We'll explain each point. अभी तक नहीं हुआ, जल्दी कीजिए. Should we move on or still writing? Okay, I think you guys are done then. Right, next, remarks. Right, first point. When activation energy is high, that will give you a slow reaction. When activation energy is low, this reaction will be fast reaction. Next point. When the energy of product is greater than the energy of reactant, in this case, the reaction is going to be endothermic. That means delta H is going to be positive. When the energy of product is less than the energy of reactant, it is going to be exothermic. Delta H is going to be negative. Okay, right, next. When colliding particles possess, what will they possess? They will possess energy. They possess kinetic energy equal to the activation energy, then the atomic configuration formed at this stage is called transition state, and it is also known as activated complex. Okay, both are same thing, activated complex या transition state के बारे में पूछे. For example, if you have hydrogen molecule like this, H2, and you are reacting this with I2. Okay, you have H2 plus I2. Then the transition state will look something like this. This H is going to form a bond with this. This H is going to form a bond with this. So that, and these H are going to break. The bonds are going to break. So you'll get a transition state in which these bonds are forming. And these bonds are breaking. And these bonds are breaking. This is your activated complex. अभी हो जाएगी थोड़ी देर में मोहम्मद उमर. सवाल बहुत रहते हैं आपके पास, सब्र नहीं है आपको मोहम्मद उमर. Art मतलब it is 1.5 hour only ना. This is activated complex. कहीं जाना है आपको इसके बाद मोहम्मद उमर? A transition state. And it is going to form what? It is going to form 2 molecules of HI. हाँ, तो नमाज आपकी छूटी है, हमारी थी ना छूटी है. There was a very good thing written in एक बस में लिखा हुआ था ये. लेट आप हैं, हम नहीं. Okay, it is for those people जो बहुत हड़बड़ाने लगते हैं. है बस ड्राइवर को जल्दी चलो ट्रेन छूट जाएगा, बस छूट जाएगा मेरा, आगे हमको बस चेंज करना है. तो उनके लिए था कि लेट आप हैं, हम नहीं. Okay, all of you understood what is this transition state and activated complex?
Yes, sir.
Yes, okay. यहाँ पे इसको मत, ये डैश लाइन ऐसे ही था, इसको हटा दीजिए यहाँ से. It's good that you write it like this, and then this is your activated complex of transition state. So, in the next class, that will be your last class inshallah, and in that we'll be learning about the temperature dependence दोनों qualitative analysis भी and quantitative analysis, both the things. Done, guys? Yes or no?
Yes,
Or
sir.
still writing? Done? Okay. Thank you, guys. Thank you very much. We'll meet on Thursday. And अच्छा हाँ, Thursday के बारे में ये कहना था. How many of you are having any class after this class? Do you have any class after this?
But tomorrow or today?
No. On Thursday.
No, sir.
No class?
No.
Does anyone have any class after this?
No, sir.
No. Anyone